Hello everybody, I wanted to post a video about how we can use Graphing Calculator to check our work. In particular, when we're trying to find a rate of change function, what I hope that you got out of today's lecture was that we have the definition. So given an accumulation function, something like f of x equals 2 to the x, if I want to find the rate of change function, then I can do whatever rules I want to do, but I can always check it against the actual definition. So what you can do is type in the definition for the rate of change function, more or less as the changes in y's, so f of x plus h minus f of x over the change in x, so over h, and then make h into a slider so that h can be big or small. And so as soon as I clicked on that, it graphed these things for me. So the blue graph is the original accumulation function, and the red graph is the rate of change function. And as I let h get really, really small, okay, the red graph is getting closer and closer to the exact rate of change function. Okay, so the red graph is our reliable rate of change function for the blue accumulation function. Okay, now if you were to accidentally confuse the power rule with the rule for taking the derivative of something of the form b to the x, and you thought, oh, well, maybe the derivative is x times 2 to the x minus 1, well, you could check yourself by graphing that function. Okay, so let's go ahead and graph it as green. And you see that this green graph is not the same as the red graph, right? And the red graph is 100% guaranteed the correct graph because it is the graph that comes from the definition of rate of change. So since this green graph does not line up with the red graph, we know that this b of x function is not our rate of change function. Okay, so then if we recall today's lesson, then we did establish a formula. So the derivative or the rate of change function for a function of the form b to the x is b to the x times the natural log of b. So in the case where b is 2, that gives us this function c. And if we look at the graph of c of x, then notice, I'll make it aqua, that, and you notice that the red graph changed to a different color. Well, that's because, look, the red, as I let h get close to 0, ends up overlapping with the aqua. And so that aqua graph, the graph of c of x, is in fact the exact rate of change function for the function 2 to the x. Okay, so if you do that, you can do this process with any derivative that you're trying to find. So if I have the function x squared minus 3x plus 2, then I would expect for my derivative using the rules to be, we'll call it k of x, and using the rules, I think that the derivative should be 2x minus 3, okay, and let me make this purple. Oh, well, actually, I need to graph it, so y equals k of x, and I'll make that the purple one, okay. And so once again, let me turn off some of these other things because that's for the old examples. Okay, and so the blue graph again is the accumulation graph. So let's turn that off so we can just compare the rates. And so right now the red graph is the rate of change graph from the definition, but I've got h kind of big right now. And the purple graph is what I think should be the exact rate of change function in closed form versus open form, which is what the red graph is. So when I let h get really, really small, notice that those graphs overlap. And so that's a way that we can check to see whether or not we correctly found the closed form rate of change function. All right, I hope that helps. You can use this technique when you're doing any and all of your homework assignments. FYI. Cool. Have a good one.